Given efficient synthesis of the following compounds from benzene, use the reactions you've learned in the acids chapter. We kind of have to specify that now because by the time you get to carboxylic acids, you have done all sorts of reactions. Okay, so there is going to be more than one way that you can make any compound, but in this case we are supposed to use only acids, okay, or derivatives. Okay, you can use those also, and we have to start from benzene. Okay, so in the first case, let's look at the first synthesis. Here we actually have an amide, and so if you have an amide can be formed from an acid and an amine. Okay, so looking at what we have here, the carbonyl is connected to the benzene ring, which means that I need to have benzoic acid here. Okay, so that carbon with the carbonyl, okay, so that will be attached to the benzene ring, and then my amine is going to have these two carbons, okay, on there. So that's going to be my starting point. So that means that I need to know how to make benzoic acid from benzene, which we have done before, okay, when we were in aromatic chemistry. And so you start with benzene and you do Friedel-Crafts on that, and so AlCl3, and you make toluene, and you can take the toluene and then oxidize it, so KMnO4, easy peasy. Once you have your carboxylic acid, then you can go ahead and now add the amine. Okay, that's all there is to it. Now, if you want to be more efficient, okay, in your synthesis, and reacting carboxylic with an amine is not really a bad deal. So which means here, let me do that first, and then we'll talk about what I'm talking about with efficiency. So let's do this first. Okay, that will give you your product. Okay, that's not a problem at all. So here we have this. But usually you would find in textbooks and even otherwise sometimes the better way to do this reaction is to actually convert this into an acyl chloride. Okay, and so once you have the acyl chloride, which means that COCl. So once you have the acyl chloride, then this reaction is a lot easier to do because acyl chlorides are more reactive. Now, which one should you do for me? It doesn't matter to me. Okay, you can give me the top one, that's fine too. Now, one of the things that I have not covered is that there is another reagent that you might, or it's sort of a catalyst, but a reagent that is used when you use carboxylic acid and an amine straight away, because this is an acid, this is a base, so you might end up getting an acid-base reaction, so you need to prevent that. Okay, and so that's why the acyl chloride method is actually a better method, okay, to form amides. But in any case, you can give me either one, it doesn't matter to me. Okay, so that is the first synthesis. Let's look at the next one now. In case of the next one, we have a tertiary alcohol, and this is also coming from benzene. So a tertiary alcohol coming from a carboxylic acid derivative, well, from what we know is that we can use Grignard reagents, okay, to make tertiary alcohols, and we need to use carboxylic either ester, we can also use acyl chlorides, and we can also use anhydrides, okay, to form to react with Grignards, okay, in order to form a tertiary alcohol. So in this case, looking at what we have here, we have a carbon right here. So that carbon could be coming from the carboxylic acid, which means that we need benzoic acid, okay, to begin with. So in that case, I'll direct you to the top synthesis that we have done, so we don't need to repeat that again. So we have the benzoic acid made already on the top, okay, so from above. There you go. So now I can convert this into an ester, or I can convert it to an acyl chloride. And I know I've done that above here also, but I'm just going to go ahead and write that again just because. So here we are, acyl chloride, and now I can treat this with Grignard reagent. So with the Grignard reagent, now I know over here I got two methyl groups, okay, so which means I need methyl magnesium bromide, and I'll go ahead and write excess of that. Okay, why? Because I actually need 2 moles, but whenever you have any reagent, it's always going to be in excess. Okay, and so that's that, and then you need to do hydrolysis on that, and that should give you your product, okay, that you need. So this carbon right here is still there, the oxygen is the alcohol now, and then you added the 2 CH3s coming from the Grignard. Now, you have to remember one thing, all right, is that when you're making tertiary alcohols using acid derivatives, two of the groups have to be the same. If they are not the same, then you cannot use acid derivatives. Okay, so this synthesis would not have been valid if the tertiary alcohol had all three different groups coming out of it. Okay, and so in this case, we had two of the same groups. Okay, whether this was methyl, it could have been methyl or phenyl or whatever, and so in those cases you can use acid chlorides, again because you use excess of the Grignard. So once you use excess of Grignard, you're actually using 2 moles, okay, of the Grignard reagent for this reaction. So you can't use Grignards, or you can't use, well, I should say acid chlorides or acid derivatives to make tertiary alcohols all the time, only in certain cases.